Hey guys, so we're going to start with lesson 2.10. Go ahead and try the warm-up. You can pause the video, and when you've tried all of these, go ahead and unpause it and you can see me going over it. If you needed a little bit of help, I will go over A of 1, 2, and 3, and then you can pause it again and try B or B and C for the other two if you needed just a little hints. Okay, so I'll start with 1A. I definitely want my t-chart for this. Okay, so my chart is 0, pi over 6, pi over 4, pi over 3, pi over 2. And my points are 1, 0, 0, 1, radical 3 over 2, 1/2, radical 2 over 2, radical 2 over 2, and 1/2 radical 3 over 2. So the first one, remember, this is saying that some angle, theta, when I take the sine of it, I get negative 1/2. And that's what I'm trying to find, is the angle that gives me that answer. So I look over here on my t-chart, and remember that sine is the y. So here I see that I have 1/2 on the y at pi over 6. When you do inverse functions, it is in only 2 quadrants. So for sine, it's quadrants 1 and quadrants 4. So this would be a negative pi over 6 because I want to go down into that quadrant 4 to make it negative. All right, let's go to B. Oh wait, I said I was going to do all the A's first, sorry. All right, let's go to number 2. So here we're finding the exact value by sketching a triangle in the appropriate quadrant. So on this one, since my cosine is positive, I'm going to be in quadrant 1. So the 2 quadrants for cosine are 1 and 2. Tan and sine are 1 and 4. Here I have cosine. So cosine is adjacent over hypotenuse. So I want my 2 here and my 3 here. Using Pythagorean theorem, I can find my third side, which would be radical 5. Now I want to evaluate the tangent of that angle theta. Tangent is opposite over adjacent. So that would be radical 5 over 2. Okay, number 3, we're going to make a triangle again. Pick your theta. And so this is the theta right here, okay? So this is telling me that when I take the cosine of this theta, I get 3x. Cosine is adjacent over hypotenuse, so I know my 3x is going to go here, and my 1 is going to go on the hypotenuse. Then I need to use Pythagorean theorem to find that third side. So that would be 1 minus 9x squared. That's a 2. It's not happening. There we go. Okay, so now I want to evaluate the sine of that angle, sine theta. And so sine would be opposite over hypotenuse. So that would be radical 1 minus 9x squared over 1. All right, if you were stuck on any of those, go ahead and try the second parts now that you've had a time to have a hints, and then we'll go over them. Okay, so let's look at number 1b. It says cosine of some angle is negative 1. On this one, because it's negative 1 and my cosine is my x, here's my 1, but it doesn't really work to make it negative 0. That doesn't make sense. So on this one, it's important to remember our unit circle. And here's the point 1, 0. So if I want my x to be negative 1, that would be here. So this one is actually pi. Okay, and then C. I want my tangent to be 0. So in that case, I have y over x. That's sine over cosine for tan. And it looks like to equal 0, I would be using that angle right there. So the answer for C is 0. Okay, for 2b, I want to draw another triangle. This one, my sine is equal to a negative 3/5. So since sine is negative, I'm in quadrant 4. Okay, so I have some angle. Sine is opposite over hypotenuse, so I have my opposite and my hypotenuse. This is clearly a 3, 4, 5 triangle, so 4 goes there. Now I want to evaluate the cosine of this. So that would be adjacent over hypotenuse, which is 4/5. And it is positive because cosine is positive in the fourth quadrant. Okay, 3b, it's actually the same setup as before. So here's my theta. That cosine would be adjacent over hypotenuse. So I have 3x and 1. And then my third side is radical 1 minus 9x squared. So on this one, I'm evaluating the cotangent. Since tangent is opposite over adjacent, cotangent is adjacent over opposite. So that's going to be 3x over radical 1 minus 9x squared. And we can leave it improper, that's fine. All right, so for today's lesson, we have, we're going to be doing the derivatives of these inverse functions. Okay, so let's look at first finding the derivative of the inverse sine function. So in order to do this, the first thing that we want to do is we want to rewrite this y equals inverse sine of x. Okay. And if I were to use my knowledge of inverse trig functions, I would remember that what this is telling me is that the angle y is the angle that when I take the sine of it, I get an answer of x. Okay, so this is my angle, and this is my answer when I take the sine of it. Okay, so if I wanted to rewrite this, I could rewrite it as the sine of y equals x. And now I'm going to go ahead and do my derivative of this implicitly, okay? All right, so we have derivative of sine is cosine of y, dy dx, equal to derivative of x, which is 1. And now I'm going to go ahead and divide by my cosine of y. All right, I'm not quite done. So what I'm going to do now is I'm going to draw my triangle like I did on number 3 of the warm-up. And so this is telling me that my angle is y and that my sine of this angle is x. So that means my opposite over my hypotenuse is x over 1. And using Pythagorean theorem, I know that my adjacent side is 1 minus x squared radical. So what I can do now is I can actually substitute this into my formula right here, doing the cosine of y. The cosine is adjacent over hypotenuse, so that would be radical 1 minus x squared. Okay, so that is the derivative of inverse sine of x. On the next page, you are going to see all 6 inverse trig derivatives. These are formulas, okay? Notice that you have chain rule kind of built into these formulas. So what that means is if I give you anything other than an x, so for instance, u, maybe u would be 5x to the 4th, for instance, on example 1, or you could be x squared, or you could be 2x, anything other than x. You have built in here that you need to follow up with the derivative of that inside stuff, okay? All right, so let's try number 1. We are going to follow this formula right here for secant inverse. And on this one, my u is 5x to the 4th. All right, here we go. So we have 1 over absolute value of u. Since x is to the 4th power, this will always be positive. So 5x to the 4th, I don't need the absolute value sign. And then radical, and I have u squared minus 1. So my u squared would be 25x to the 8th minus 1. Since my u is not a plain x, I need to times this by the derivative of u, which in this case would be 20x to the 3rd. All right, let's try example 2. On example 2, we do want to rewrite this And we want to rewrite it as inverse sine of x to the negative 1 because the sign is in the denominator. This will be much easier than quotient rule. Okay, so we're going to use chain rule on this. And remember, with chain rule, the first thing we want to do is bring this down into the front, and then we're going to minus 1. Okay, so we have negative 1 inverse sine of x to the negative 2. Notice I didn't change anything on the inside of my parenthesis because I'm doing chain rule. Okay, so that has to stay the same for that first step. Times, and now I'm going to do the derivative of my inverse sine, and so I am using my formula up here. So this would be 1 over radical 1 minus x squared. Notice on this one my u is x. If I want to times by the derivative on this one, the derivative of x is 1, so I could put that times 1 or I could just leave it off. All right, let's look at the last one. Derivative of x inverse tan of radical x. So on this one, we are doing product rule because we have the x timesing with the inverse tan of radical x. And then notice on this one, my u is radical x, okay? All right, so let's go ahead and do product rule. So we have derivative of the first, 1, times the second. Don't touch it, leave it alone, don't do the derivative yet. Plus derivative of inverse tan, so that would be 1 over, I'm using this one right here, 1 over 1 plus u squared. Since u is radical x, when I square it, I just get x. Times derivative of the u. So in this case, it would be 1/2 x to the negative 1/2 times the first x. Okay, so let me just show you really quick. Here's my derivative of the first times the second. Here's my derivative of the second times the first. Okay, and that's product rule. Okay, so this is my full answer here. All right, you guys are going to be trying your homework. I will be hooking up with you guys on Thursday and Friday via FaceTime to go over any questions you might have. So make sure you're taking little notes in the margins if you have specific questions that you want to ask me so that you can remember those. When we see each other, please make sure all of your homework is tried so that when I do FaceTime you, it's not just me watching you do problems. It's kind of a waste of your time. So have those done with specific questions that you want to ask. And I'll see you guys soon.